Hello. So now we're gonna do this problem, okay? David's cookie jar had 85 cookies last week. This week it had 68 cookies. By what percent did the number of cookies decline this week? So in this case, they're asking what percentage was the decline. We can tell that since last week it was 85 and this week it had 68, they could have said what is the percent change, and we would have known it was a percent decline. Okay, I just want to point that out to you here, obviously. And the first thing we're going to do when we're going to start to set up this problem is we're going to list what the problem statement gives us so that we can then think about the proportion that we're going to set up. Okay, let's do that together. So here I have my setup, right? I need my before, my after, and my x. So it had 85 cookies last week, and this week it had 68 cookies. So we know that 85 is my before. It's my before value. And 68 is my after value. And of course, we don't know what the x is, so we're just going to leave it as x. Okay? And so now we're going to set up the proportion, the standard proportion for dealing with percent increase and decrease problems. So here, for example, we know that our after is 68, so let's put that here. We know that our before value is 85, so let's put that here. And then we're going to solve for the x, so I put my x here and I put my 100 here, right? And so now what we do is we look at our general rule for proportions, right? So if A over B equals C over D, then AD is equal to BC. Okay? Yes. So here, what that means is that I'm going to take my A times my D, and I'm going to equal it to my B times my C. So in other words, the 68 times the 100 will equal to 85 times x. Or in other words, 85x. Okay? Now I need to multiply these two together. Let's do that together. So 100 times 68. 8 times 0 is 0. 8 times 0 is 0. 8 times 1 is 8. 6 times 0 is 0. 6 times 0 is 0. 6 times 1 is 6. Now I'm going to add these together, right? 0 plus nothing is 0. 0 plus 0, 0. 8 plus 0, 8. Okay? And then I bring down the 6. Okay? So that gives us 6,800 equals 85x. By the way, I want to point out something too that I haven't pointed out yet, but I think it's time for me to point this out to you. Notice I'm multiplying 68 times 100, and look at our result. 68 with 2 zeros at the end. So in general, if we have a number, like let's say 3, and we multiply by 100, we just affix 2 zeros, okay? 20 times 100 is 2,000, because we have the 20 and 2 zeros, okay? And if it had a decimal point, like let's say 2.23, and I multiply by 100, we move the decimal place 2 places to the right, okay? Anyway, but you can always do it long like I did it there. There's nothing wrong with that, and I want you to be confident in doing that, okay? Okay, let's do this together now. Now, I'm going to divide both sides of this by 85 to get the x by itself, right? Because what we're really interested in here is my x. Because the x is going to allow us to evaluate what the percent decrease was. Okay, so x is 6,800 divided by 85. Now again, I'm going to make my multiplication table. And then we're going to do the long division. Let's do that together here. Okay, good. Yes. So, by the way, I want you guys to notice when I'm doing my multiplication table that it's always just the digits 1 through 9, because that's all I need, right? Because when I'm doing the long division, I can only put one digit at a time on top. Those digits go from 0 through 9. 0 times any number, 0 times any number is 0, so I don't have to even put it in my multiplication table. The ones I have to know are from 1 to 9. And again, also, by doing it this way, when I'm actually performing the long division, I don't have to go back in my brain and start thinking what could be a possible number that multiplies to give me whatever the quotient is at that moment in the division process. I can just go straight through. And let's do this together. Okay, let's do this. So obviously 1 times 85 is 85 because 1 times any number is just itself, right? So now we're going to start adding 85 each time. So 85 plus 85. 5 plus 5 is 10. I bring down the 0 and carry the 1. 1 plus 8 is 9, plus 8 is 17, okay? I add 85 again here. 0 plus 5 is 5. 7 plus 8, that's 15. I bring down the 5, carry the 1. 1 plus 1 is 2. That's 255. Okay? I add 85 again. 5 plus 5 is 0. It's 10. I bring down the 0, carry the 1. 1 plus 5 is 6. 6 plus 8 is 14. So I bring down the 4, carry the 1. 1 plus 2 is 3. So that's 340. Then I add 85 again. So 340 plus 85. Okay? 0 plus 5 is 5. 4 plus 8 is 12. I bring down the 2, carry the 1. 1 plus 3 is 4. So that's 425. Okay. Okay. I add 85 again. 5 plus 5 is 10. I bring down the 0, carry the 1. 1 plus 2 is 3. 3 plus 8 is 11. I bring down the 1, carry the 1. 1 plus 4 is 5. So that's 510. Then I'm going to add 85 again. 0 plus 5 is 5. 1 plus 8 is 9. And then I bring down the 5. So 595. Okay. I'm now going to add 85 to that over here. Okay. I'm sorry that this is getting a little bit cluttered, but I hope you'll bear with me. 5 plus 5 is 10. So I bring down the 0, carry the 1. 1 plus 9 is 10. 10 plus 8 is 18. So I bring down the 8, carry the 1. And then 1 plus 5 is 6. That's 680. And then I can add 85 again. 0 plus 5 is 5. 8 plus 8 is 16. I bring down the 6, carry the 1. 1 plus 6 is 7. Okay? Now, you guys might ask yourselves, David, we're all human. How can I verify to see if I've made a mistake or not? Now, although it's not a perfect technique, one way that you can do it is you can multiply 9 times whatever number and see if it gives you this digit. If it does, it's not a guarantee that you did all the addition correctly, but it's a pretty good sign that you did it right. Okay, so I'm just going to do that here as a double check. I guess this might actually be a sign when you might get the sense that I'm slightly paranoid when I'm doing calculations. But sometimes you have to be a little bit paranoid. 9 times 5, that's 45. So I bring down my 5, carry my 4. 9 times 8, that's 72. And then I add 4, that's 76. So 765. So indeed, because that digit matches the digit I got here, which it should, then it's highly likely that this table is correct. Okay? Okay. Now, we're going to perform the division. Okay? So remember, when I have the division I'm going to perform is 6,800 divided by 85. I'm going to put the 85 on the outside of the house and the 6,800 on the inside of the house. Okay? So then I ask myself, does 85 go into 6? No. Does 85 go into 68? No. Does 85 go into 680? Aha, it does. And because I'm in this table, I can see, aha, it goes in exactly 8 times. Isn't that crazy? 8 times 85, that's 680. Right? Okay. So now I can ask the question, what is 0 minus 0? 0. 8 minus 8? 0. 6 minus 6? 0. Then I drop this 0, right? And now I ask myself, how many times does 85 go into 0? It goes in 0 times. 0 times 85, that's 0. 0 minus 0 is 0. There's nothing left to drop, so that's when we stop the division. So that number on top, which corresponds to our value of x, is equal to 80. Okay? Okay. And so now, once we have reached this point, we're going to interpret it based on our original rules. And let's do that together now. So we recall that if the x is less than 100, then it's a percent decrease. Okay. Let me write this as a, yeah. Then it is a percent decrease, of course. And we, of course, expect that given the situation of the problem, right? It's a percent decrease. And the amount of decrease, and that percent decrease is given by 100 minus x. Okay? In our case, that x is 80. So this will be 100 minus 80. And what is 100 minus 80? That's 20. Right? And so now we can answer the question. What was the original question? By what percent did the number of cookies decline this week? The number of cookies this week declined by 20%. Okay? Yes. I rewrote it here as a sentence, the way I would want you to write it down in your notebook. The number of cookies declined this week by 20%. Okay? And I promise, if someone out there has my cookies, they're not gonna hear the end of this. Nah, just kidding. That last part was a joke. But yes, that's how you write it, and I look forward to seeing you again soon.